And next up is Matt Peterson, Office of the CTO from Cumulus, here to talk about it. Help me welcome Matt.
Thanks very much, Cole. So Office of the CTO is a pretty vague title. And what that means for me is both fun and exciting projects, and sometimes myself as the instigator of those projects. When you look at the modern data center today, users are demanding flexibility where their applications are deployed and what underlying infrastructure. So for example, that could be Puppet for configuration management, OpenStack for the orchestration, Ceph for storage, and Dell hardware. What's important here is all of those components are decoupled. You have a choice of the operating system, the underlying hardware, and of course the applications. But as Cole mentioned, networking has traditionally been stuck in the past. Traditional networking appliances are arcane. They're very difficult to do provisioning in a bulk fashion. Most importantly, the hardware and the software is coupled together, so you don't have a choice of whether you want to use different software on different hardware. Now, as we've seen with Open Compute, particularly with the presentation yesterday from Aaron from Rackspace, is that when you adopt an open ecosystem, you have a number of benefits. The first is that you can move innovation forward, you can drive down cost, and you can improve performance. Now, who here likes PXE, right? PXE is a wonderful protocol that was developed several years ago. It's almost a decade old from its original implementation. And PXE can be a nightmare. And the reason I put the Band-Aid up there is that PXE is typically so frustrating that most users will actually chain boot to an additional PXE stack just to get rid of some of the limitations of the built-in PXE ROM that's in their NIC. So to me, that's a Band-Aid solution, and it's really frustrating. Now, you may ask, well, if you're purely from a networking background, why would you care about PXE? Well, in a previous life, I ran the data center and network operations for a blogging company and a financial startup. And in those environments, we had a non-trivial amount of x86 servers. And so I got to learn about PXE pretty hands-on and extensively. And there's really three main issues with it. The first is that it's console only, right? So it's very difficult to debug. There's no remote login capabilities or logging that you can see what's actually happening over the network. It's only available locally at the console. The second is it's stuck in a 90s era of networking, right? So that's IPv4, TFTP, single-threaded, right? PXE is not much more powerful than, say, an Arduino, right? It's very limited networking capabilities. And the third is that it's niche support outside of x86, right? So if you look at PXE, it was geared for x86. And as the data center and the infrastructure is growing, you see other architectures such as ARM, or even legacy architectures such as PowerPC that are gaining traction in the data center. They don't get to take advantage of PXE. So the summary here is that when you want to decouple hardware from software, you need modern, robust, and efficient provisioning systems. And now it turns out that there's a long history of operating system vendors building networking boot protocols. And you think about this, it's almost kind of like a natural facilitator. It makes a lot of sense, right? The OS vendors, they want to be available on a broad range of platforms. And the hardware suppliers, they want the largest set of end users possible. So it really benefits everyone. And these protocols are not necessarily new. You know, NetBoot has been around for over 20 years, originally starting from Solaris with Sun. Apple has a network booting protocol. PXE originally came from Microsoft and Intel. And now we have ONIE from Cumulus Networks. Now, ONIE had a few high-level design guidelines. We call these kind of design principles, if you will. The first is we wanted to enable choice of the operating system. Now, obviously, we'd prefer you to pick Cumulus Linux, but you could pick another operating system if you chose to do so. So mixing and matching, giving freedom to the end user. The second is it didn't make a lot of sense to reinvent standards that already existed. Right? So if you look at things like the standard BIOS from Award or AMI, there was no reason to get rid of that or re-implement that. The second is things like U-Boot, BusyBox, HTTP, DHCPv6. These are great protocols that are well understood. They're well documented, they're really easy to describe and debug. So we didn't want to throw those away. We didn't want to reinvent the wheel, we wanted to keep those. And most importantly, when you look at modern open source projects, they require quite a bit more than just a mailing list. So we started off on our GitHub repository and built extensive documentation, not only for developers such as hardware manufacturers, but also for end users. And I think what's important about our documentation is that it actually includes real-world examples. So you can dig right in and build up an ONIE environment. Now, as Cole mentioned, ONIE doesn't replace a standard initial bootloader. So in the case of ARM or PowerPC, you would probably use U-Boot, or the Universal Bootloader, a project that was actually born in Europe. And in the case of x86, you'd probably use a traditional commercial BIOS, or maybe Core Boot, an open source BIOS. ONIE acts as a second stage or an additional bootloader that focuses on installing a network and operating system. And in addition, it can also provide some rescue and some debug functionality. When we look at the actual implementation, we decided to build it off of BusyBox. The reason for that is BusyBox is a well-understood embedded Linux distribution. So if you look at the OpenWRT movement, that was built originally from BusyBox. The great thing about using Linux as a base is that we get reliable and consistent drivers that just work. We have three main processes that ONIE enables. The first is bringing up the network. Now that may be doing DHCP-v6, it may be doing IPv6 neighbor discovery, may be doing traditional DHCP-v4, and of course, in a worst case scenario, falling back to static IP address for IPv4. The second phase is discovering an installation image. And as mentioned before, we use modern protocols. So in the case of PXE, all you have is TFTP. And so for doing any sort of robust implementation of TFTP, the typical implementation there is to do a waterfall of different file names to match. With ONIE, we're leveraging modern protocols like HTTP. So with HTTP, we can actually send request headers that include the manufacturer, the serial number, the MAC address, metadata that your provisioning system can read and serve up the correct image. Once the image has been fetched down, we then run an unattended installer. The unattended installer uses some infrastructure that ONIE provides. So those are things like a makefs file command, things like iftool, basic guardrails to get the environment installed in an unattended fashion. Now what's important here that I want to keep driving home the message is that these are all modern protocols. When you look at PXE, it's not modern. One of our goals was to cut the cord, to not use a console cable anymore. If you're using a console cable, you've failed. On servers, most administrators are used to using IPMI, and when they have to use serial for LAN, that's a worst case scenario. Typically one they don't enjoy doing. It's the same with networking. We need to get rid of the console cable and move forward. One of the things that's great about ONIE is that we have a lot of powerful remote debugging capabilities. So you have things like syslog, and you can SSH in or telnet. So it's very powerful to find out what exactly ONIE is doing. It's very simple to tail a log and see the state. Now the great thing about ONIE is that, as Cole mentioned, we started off initially for Cumulus networks as a way of disaggregating the hardware and software. We had to build this to enable our product. And when we made it available to the OCP Foundation, it's really blossomed. And there's really two interesting efforts here. One is not only does ONIE enable this disaggregated market, but it also, because it's part of OCP, has a strong certification component to it. And so what that means is that when a manufacturer adopts ONIE, part of the OCP spec is that they have to not tamper the environment so that any operating system can install in a consistent fashion. Part of that certification also includes things that are physical attributes, so how a switch is silkscreened or labeled, and also things such as putting an asset tag or a serial number on the front and rear. And that's something that's frustrated me for a long time, is that why would I buy rack mount equipment where the only label or designation item is on the top or the bottom? Because once it's racked in, I can't see that label anymore. So we've tried to adopt, again, how to scale out organizations for networking at scale for a data center. There's a lot of problems that people run into, not just on provisioning at the software layer, but also at the physical layer. So when we look at the adoption across the market, initially we started with one operating system, one architecture, and 4 different hardware partners. Today I'm proud to talk about the fact that we have 7 hardware vendors, over 25 SKUs available, or 25 products available, and 3 different operating systems. And just this morning, we added support for ARM. So now we have 3 architectures that are supported by ONIE: PowerPC, x86, and ARM. And early next year, we'll see other ONIE products available that don't use Broadcom chipset. So you'll see other chipsets in the market available. The 3 operating system vendors today that are publicly known or acknowledging that they support acknowledging that they support ONIE would be Cumulus Networks with Cumulus Linux. As of October, Peak 8, their Peak OS, and as of early January, Open Network Linux from Big Switch Networks. As mentioned, there are a number of hardware partners. Now, some of these are kind of household names, if you will, like Dell or Quanta, certainly to this group. But there's other brand names from ODMs that come from Taiwan, China, Israel, Canada, and of course, America. In conclusion, ONIE enables the open networking era. And I think this is really powerful for OCP. When you look at open hardware designs on the server side, we're now adopting that on the networking side, and that's very powerful. Now, we also have a special announcement today to talk a little bit about some of the growth that's available for ONIE outside of the networking space. Please welcome Mark back to the stage.
I think this is a very good example of the sort of serendipitous collaboration that comes out of a forum like this. First, I would want to echo everything you said about the legacy protocols that have traditionally been used for physical provisioning and installation. And to say how great it is that the modern approach that you guys have taken has landed up at OCP, where I really believe it could become the foundation for the next wave of physical provisioning and essentially disaggregation between the platform providers and the many OS alternatives that are out there. So based on conversations here at OCP, we've committed that we will contribute support for ONIE to MAS, so that you'll be able to use MAS to do physical provisioning for ONIE-based systems and for operating systems that will use ONIE as their sort of delivery vehicle. And we're really looking forward to collaborating with your team and the OCP community to take ONIE well beyond the switch. There's an enormous opportunity for a whole range of devices, servers obviously, but other networking devices. And ONIE looks like a superb foundation for that next iteration. So thanks for the invitation.
Thanks very much, Mark.
To talk about that.
It's great. Thank you very much. Cheers. Thank you.